You should have papers for me. Your homework assignment should be physically on paper, on it. If you have multiple sheets, make sure you have them. If you tore it out of a notebook and you have scissors on the edges, tear those off. Scissors, if you have a different, most of your notebooks should be perfect. Once you have them, send them to your and I can just go down one edge, pick them all up. Carter, 1, 3. We were I have a bunch of histograms for the price and after a histogram that looks like this. Now you are not required to do this on or we did it in Excel. And I have it here. Bins of width 8 has bins of 10 in the same way that this is with 10. But then I did one with 5. That had bins of width 5. What the hell is that? That red thing. Well, it's called OGIVE. OGIVE. What it is a line that the cumulative frequency. So we made the table. You have the from Friday. We have the frequency written. Pull up that table for me. So, numbers, earnings ratio less than 5. That first bin is 0%. Notice next to our frequency, when you select the histogram option, you can ask it to include that's your choice. Include it, your data includes that table. You can add under our histogram, when we go to insert data, we get analysis little grid in the upper. When we tell it we want a histogram, options, options from the bottom. It generates the ogive, that curve, a line cumulative. It could, at the end, be 100%. We saw when we did the attack, we had some rounding issues. When we do it mechanically, it should not completely top. Now, because this is a slightly different histogram we generated the table for, this is bins of 5, things in the shape of the histogram itself. Tallest group. Divided by tens. We get a tallest group. Referred to as a modal, M-O-D-A-L, a modal class. In with the largest values in it. This is a uniform set of data. Binary data equally high. You can have multi-mode data if they're all the same height. Definition for mode, more on that. Let's talk about, is this symmetric? More is on the left. That means there's a L extending out to the right. The side with the lower L is the direction of skew. So this is considered to be skewed. The long tail extends to the right. If you consider that modal class somehow, if you had left below extremes and a lot on the right, then the two tails of the. So page 60 has a pretty picture of several different kinds. And symmetric right, and is uniform. There's one peak. Figure 3-3. But in the lower two there, lower three, I got skew right and skew left still. These have two different relative peaks. Here, I could have all sorts of options. Sometimes there are gaps in classes. Our data, those are all connected. The groups are wide enough that there's no actual groups that are empty. When I go out to 5, there's nobody between 50 and 5. There's an empty spot in the middle. That makes that edge there an outlier. Beyond what we reach of our picture, of our histogram, a skewed left, outliers down towards the left. Skewed right will have outliers. The middle one is symmetric. Those gaps between. And depending on the size, our outliers may or may not be attached. Strict or bin choice. We need a more precise identifier to measure how wide or narrow our data is. Here, far out effects on our image and on the numeric for our data. When you see skew, it is likely going to increase the number of bins you're using, simply because it allows you to get a finer detail as to what's going on. I said was a line graph. I could replace this with dots of each bin and create on that histogram. So here's the shape of the histogram, right? that into just 6 dots. One at a height of 6, one at a height of 9, 4, 2, 1. Then I get this here on the left, this free polygon. I don't get this anywhere near a histogram because to me, seem to relate to more rather than when I see this going up is a somehow there's some sort of factor correlative behavior. You know what that form means. But that is you go from left to right in an node, increasing your cumulative frequency. But right is actually as things should be going up. Increase your frequency, you should go down. The left picture histogram character. So while you can, I don't think it's as helpful. Questions? How many of you have BU110 Excel business software? Thousands of Excel. And so as we ate with it, there are more options in Excel to know what to do. And I don't mean charts. They're useless. Bar chart is kind of chart that bars like this make it impossible to compare hierarchy. Area reverse. There's a lot of options in tool ribbon Excel where you can get different pieces. The default setting for boring. And if you have different colors, or want to use a different font, or any of different background, whatever you want, it's up to you. But the purpose of a chart is to clarify, make it easier to the data that was thrown at it. Just a picture can light its ass off. You'll notice there's a category that says more, right? That category there. We can literally delete it out, and it deletes it from immediately. Which then means we could adjust the size that's laid out. A little shorter without that label on the right. I can adjust the vertical axis here. Goes up. Here are two different line charts that are related. Page 70. Across the bottom, we have 1980 to both sides. The same. What again? Look at the y-axis on the left. Each mark is 500. On the right, each mark is a power of 10. The distance from here is multiplication by 10. here to here is technically 10 than the distance from here. The scale, it shows that same increase that the picture on the left shows. Simply by additive scale, a linear, to a multiple, a logarithmic or exponential scale. Choose to do scales. Again, as we adjust an axis, I can go over to this axis and write on it, format axis. And all these come up. Way down here on the bottom, it says logarithmic scale. Do we double it? We go up by a power of 10 every time? We go up by a power of 5? Now, why would I do that? Well, originally, logarithmic biology. You can grow rate proportional. So population so often. In bio 1, they talk about bacteria all the damn time. Until we have a colony. Well, then in logarithmic scales. Easy to deal with. Dealing in straight lines. So they prefer logarithmic scales. But you can put them in any place. Adjust your axes. You can adjust major and minor. So I could make lines as well as those horizontal lines by adding line chart look depend on time. I prefer it to time series data. Whereas a histogram, so here's another key to me. My data type, sort of visual. I forgot to re-maximize because I keep switching back and forth. I apologize.
Why would you want to use a bigger anyways? Because like it makes it harder to read the chart.
Jones yesterday. Closing number. $4,800. If you had asked that question to me as an undergraduate, it would have been a 4-digit answer. In 1980, the stock market had crossed 1,000, not 4,000. What's the graph look like? It gets really big in the last 2 years. Here at the beginning, right? See distance and distance here, maybe jumps here. The scale, then that looks more linear to be logarithmic, and then I can actually see all the little get smooth. So I lose some of the clarity of that. I increase my ability to see a trend. And again, it's a trade-off. This is what a larger graph and the section that I'm particularly in. More questions? So let's suppose I have pieces of data, by data, X, I, some set of I's. Let's goes from, so that's my, we're just having one set of two. Rather than just plot separately, I might want to see if they're related to each other. And in this sort of examination, it's probably easier to figure out related somehow, graph them relative to each other rather than graphing them in. Rather than create a single plot, what's called a scatter plot. And assume data are actually, graphs them like a point. So every point gets an x coordinate, and I get a graph that actually like shots to one another. Now, again, this is best done numerically. Ratio. There's a 0 in that axis. If I only had interval data, I can get as much as I want out of a cell. It's still possible with interval data, the axis itself might be meaningful. I could do responses on a Likert scale over a survey. Every day you come into class Friday, I'm going to ask you to take out your phone and answer for me. And this survey says, how stressed are you today? No stress. Or, get out of here. Track all of the data over time with a 1 through 4. Right? Or I could take the class this day, this time, right? And so I can date across the x-axis, across the y-axis, student number, random, I don't want to be identified who's who. Student number. But kind of figure out relationships between the of the semester and stress levels, looking at the comparison between the data. Page 72, we have some scatter plots. Now, not telling me anything at this moment. Okay? What that upper chart says to further through the semester, the more students are. Make sense? In the second one, as we go, be up the, it's not as tight together, is it? So while this is relation, some sort of relation between these two, and it's positive, left side, right, I don't see a relationship at all. Some of the semester and some the hell out. Sure. I got it better. My level goes down. Anybody who does. Maybe it happens not for others, all the downward. The relationship is line. Scatter plots are really good at finding straight relationships and at finding relationships straight line. Now, we'll how to create our scatter plot, which means I'm data to do it with, right? And so this data, frequency, only do frequency. I need different data. You really want to piss somebody off gas prices, because that's accurate. Maybe gas was $1.70. There's nobody they couldn't sell, right? It's about $3.55. It's down because we're switching from summer formulas to winter formulas. I just copied life easier. I put it on the. But what I did is I created a scatter. There's one piece of data for each one, right? The clustering that we got before. So how did I do this? Well, again, I go to insert, and up there on the ribbon, there's in the middle where it says recommend. And in the middle column, or at the bottom, it's scatter. I click on that with two columns, connections, I can do it. I can do it with straight lines. I can do all on this. Then I can. Do you think relationship gas prices? This sample of data. Do you believe that as gas prices are going to continue to some effect, or do you think there's a random trend? Is there a line that minimizes the error, values, actual values? Now, figuring out what the line is not until chapter 12. It's called a regression. We can ask how my change in gas and how it's attributable to something else called relation coefficient. Both of those in Excel. Mathematically. It's possible data format data series that it says add trend line. Now there's some pretty big line and ask it. That's this R here. R itself is the distribution. Again, we'll talk about in chapter 12. Ask it for the so I can make predictions. And it tells me here by 0.117 at 0.1129 price. It is right. Plug in 2024. What are the expectations? times 204 plus 0.1129. That's, I got 400 wrong here, man. The wrong thing is, I don't know. Oh,
Are you supposed to?
place. Am I supposed to? $404, and that doesn't make any sense at all. Maybe I'm supposed to do something else. See, this is my did to you. Computer did magic, and I don't like that. I don't try. So I'll figure out what the computer get that, because I think it's also. I trust the computer to do calculations. That ain't right. We'll have to know what went wrong. Let me go back to the line. Set requirement set. Figured out. Minus what? Maybe. That would be baseline year. Distance from 1965. Right, but it doesn't say that. I don't know if that's right. Well, that gives me 1190 again. I hope that, again, I don't know what this is supposed to be, and as much as I love Excel, it did. Trend lines are useful even if I don't like the equation. So let me get rid of the equation. There. That is, well, then my prices are going up for the next couple of years. How accurate is this? We just saw that's accurate at all. But tell me roughly what we think happens. With the same exact, I created a column chart. There's a histogram. There's a separate column and bar. Notice the difference. The vertical bar, other than that, it's the stacked bar, as you see color on top of the other bars. Color is next to another. Stacked. It's much easier to use versions, regardless of the effects or not. These versions are really more helpful. But that my labels are not all that, since they're easy to read in this column chart. If your labels are long in a column chart, they might, in that case, a bar chart, more rooms for the labels. I would point out to you that on page 7, there's a column. Find one column chart. What do you think of that? Because technically, stacked columns like these. Can you tell me if the number 10, when not by the numbers, yes, not the same for each one. It's different what the category is doing as opposed to one. What are the colors? Which is the most recent year? The one on the left. This is backwards in time from the right. That's annoying, because if you look at the thing, for today, I did in 2014, the answer is yes. Up as we go from 20, but that's going this way. Infuriating. As hell, isn't it? Now, this isn't numerical in one axis, right? Not even. There's no numerical difference. I don't know. That's that. As a matter of fact, type is for TO. Alfredo 1900. Where what you do is you look at the people are responding to that up to 100%. So we have again of the information largest to smallest. Well, Pareto, the person who said that 80% of 20% of your issues. Big things in the middle. Well, this allows you to focus on what the big things are. What people about in a concession. People go to the concession complain about being cold. 80% of the complaints. Lines are too long. There's no vegetarian option at a concession. Okay, at a concession stand. Too much ice. Servers. There's like maybe two people. No, the servers are dirty. Stand. I didn't for my health. I came here for a chili. Not either. So the Pareto principle actually says that you focus on the first few of your relative sign right here. Three categories. Lots of different visual charts, pie charts, hierarchical charts. It's a higher. Bought it from retail outlet. I bought it off the web. Bought it off another student. That percent actually telling me chart. Nice enough to label. But again, to assess visually without is basically how much I bought at the bookstore. Bought another student. That one. The reason why charts free is because day-to-day. About the physical day-to-day put out. USA, the first newspaper printed in color. And then on the front, above the fold, every slide. Eventually, they would move it on the page. And that quick fact was almost always as a pie chart. And see the colors in their color. Again, though, in my pie chart, because I'm rounding percentages, it's problematic. If you took Dr. Worth, looked at pivot tables. Tables in general draw you important. Now, tables with earnings. Well, that's going to be important for somebody working at. I'm going to want to be able to do that really quick. Okay. Again, I think the backwards though. Most recent, crazy. I would rearrange and say, oh, look, income's going up. 1,600, 300. Actually, billion to 2 billion. Why did I do that? Units are 16,000. Attention to read that right? $1,600? No, you made $100 million. I really can't read. And after this, the table starts to get crowded and awkward to read, and a pivot table, extractive table, range and free data that. What we can relationship change useful for large, and pivot tables in general can be used summative for us. I will be moving through this quickly to actually this summative get any obviously that's up at least one. Where is that? There it is. A wonderful book came out. How to Lie with Statistics. Paraphrased from Simon's Mark Twain. 3 kinds of lies. There are damn lies and there are statistics. Visuals even worse. When I create a visual image, I can make all sorts of differences that really don't do anything in easy ways. If we have ratio data, which pictures here are before show change? That one, right? Is the one on the start at 0. It starts at 2.1 to 3. Does it? But over here it looks my axis is large. I can my axis too small. I can put them away. Axis smaller top. I look like all right. No change in the length. Don't call anybody. Phone is a text much, but again, same graph. All difference, smaller from left to right. Looks more dramatic. And data on the left and the right. What purpose do those two have in complaint school application? Bunch of surveys and a bunch of documents. And why tilted? What the hell are you doing to my picture? That makes that left bar look even smaller than it is. Again, 0, it starts at 1,000. Whereas on the right, much clearer. Major look a lot. You might not even notice that that angle is changing. That's why I hate whether the red bear here different color, different red, different. Disgusting, isn't it? If other images of this one, the data on the right are the same. How did they do over there on? Only made the bar wider. That sudden makes it even the right change. The right picture all the same width. You're estimating your data. You write it down. And all of these need to be smart. The picture is not enough. Do something. Hey, jaded. Have posted all these and several others. means 2 days from chapter. Start looking at how much of it and what you don't. Mr. Warfield, you came in late.